I've had a little more time to think about this since I'm towards the end of the line. I think that the simulations of the Colorado flood that we presented could be done with current technology in about 4 days after the reanalysis became available. Reanalysis takes about a month or more after a given day, so maybe one would substitute that with, say, a forecast result. And you'd need a team of maybe 7 or 8 people, of which at least half are technology folks, to help do with the data. You'd need a day to set up the run, day or two to make the ensemble, and at least another day to post-process. But that's not the limiting factor. In our study, it took us longer to make the runs, but it took us way longer to figure out what was going on. We had this super Clausius-Clapeyron result, which is relatively unusual and not well explained off the top of our heads. I had thought that an increase in wind speeds that we saw was the culprit, and that was causing more uplifting on the Front Range. Pardeep did not believe that, and he was right and I was wrong. And in fact, he figured out that it was an increase in convection, and that was causing the increase in winds. So the increase in precipitation caused the increase in winds, not the increase in winds caused the increase in precipitation. And that took us a year. Now, every event's not going to be that difficult. Some might be more. And so I think it would take, maybe 4 days to do it, but it's going to take somewhat longer to make a statement that you're comfortable with.
Curiosity killed the cat.
Yeah. I would have done it quickly, but Pardeep was more careful.
Flooding, we'll start with Michael. You gave a very specific example, but if we think very broadly about flooding events, whether they're rain dominated or otherwise, would you agree that we generally have good enough data to characterize them, that for modeling them appropriately you'd need a high resolution atmospheric model, and that the challenge, as you just said, the main challenge is interpretation?
Yeah, I think the data is reasonably good, especially in the United States. Mm-hmm. Maybe not elsewhere. But I think we also need to draw a distinction between relatively brief events like the Colorado event and longer-term seasonal flooding. And for the major rivers, like the Ohio or Mississippi or something.
So those will be those will be snow-dominant floods.
Possibly, or combinations of rain on snow, causing early melting and things of that nature. But coarser resolution models may be, CMIP 5 class models might, I think, are in fact informative for such problems.
Okay.
Because it's a seasonal thing that you want to get at instead of a very intense particular storm.